When many of us think back to our own science classes growing up, we probably had a pretty picture of a traditional setup. The teacher stood at the front of the class explaining concepts, introducing vocabulary, guiding us through notes or textbook readings. We listened, we wrote things, and later showed what we knew through worksheet quizzes and short answered questions. Even when labs were included, they were often very structured. Everyone followed the same steps and ended up with the same results. There wasn't much room for questions, collaboration, or curiosity. Learning was more about memorizing facts than truly understanding how science works. Now let's compare that to what an inquiry-based science class looks like. In inquiry-based settings, students take on much more activity role in their learning. Instead of being handed all the answers, they start by asking questions, making predictions, and investigating what they observe. Students talk through their ideas, collect information, and share their thinking with classmates. The teacher's role shifts as well. Rather than leading the step by step, we guide by learning and asking thoughtful questions, listening careful to the students' ideas, and stepping in when support is needed. In an inquiry-based situation, students work together, explain their reasoning, and use evidence to support their ideas. That process helped them make real connection through science concept instead of just memorizing information. Research and classroom experience both support this approach. Students tend to be more engaged when science lessons are inquiry-based, especially when those who learn in different ways or need additional support. Hands-on investigation, working with peers, real-life example, and visuals give students multiple ways to have this content. When students have time to talk things out and reflect on their learning, their confidence grows. Showing support like guiding question models, sentence framing, and flexible grouping help more students participate instead of feeling stuck or left out. These strategies work because students are actively doing the learning. They're actively learning, not just listening. This connection directly to the conservativist theory, which tells us that students learn best when they build new understanding of what they already know. Inquiry-based instruction allows students to explore ideas, test their thinking, revise misconceptions, and learn through interactions with others. That's where deeper understanding really happens. When we compare these two approaches, traditional instruction may help us cover content quickly, but inquiry-based teaching helps students truly understand the concepts, build problem-solving skills, and retain learning over time. It also creates more inclusive classrooms by giving students different ways to engage and share their thinking. Inquiry-based science naturally supports culturally responsive teaching. It values the student's voice, the background knowledge, and lived experiences. When students can connect to science to their own lives and communities, learning becomes more meaningful. Teachers who are culturally responsive are mindful of those assumptions, recognizing students' strengths, and create a classroom where every student feels respected and included. These connections can be easily missed in traditional disconnected instructions. At its core, inquiry-based science isn't about abandoning structure. It's about creating a space for the students to have curiosity, collaboration, and meaningful learning. Giving this to the students is an opportunity to see them what they are capable as scientists and students.